Good morning, ladies and gentlemen. Today we are on page 117, and our problem of the day is we are going to review how to divide with decimals. So the first problem I'm going to do is 56 hundredths divided by 8. Okay, so what I like to remember is kind of this in and out idea that the first number is my dividend and it goes inside, and then the second number is my divisor and it goes outside. So I'm going to put 8 outside and 56 hundredths inside. The next thing I do is I double check that there's not a decimal on the outside. There may not be a decimal in your divisor. Since there's not a decimal in my divisor, then I just bring this decimal straight up and I divide regular. So 8 cannot fit into 0. 8 cannot fit into 5. 8 can fit into 56 7 times. But the 7 has to go on top of the 6. So 7 times 8 is 56, and I'm left with nothing. Now the problem with leaving it like that is I have this empty space here. So this 7 is in the hundredths place value, not the tenths. So I have to make sure there's a 0 there to make sure my answer is clear that the 7 is 7 hundredths and not 7 tenths. Okay, let's try another one. What if the problem was 1 and 25 hundredths divided by 25 hundredths? Okay, so again, we have this idea of in and out. So our divisor is 25 hundredths and our dividend is 1 and 25 hundredths. Okay, so when I do this problem, I look at the divisor first, and the problem is there's a decimal outside. There can't be a decimal outside. So what I need to do to solve that problem of having a decimal outside is I need to move it 1, 2 over here. So when I moved it over here, it's now 25 decimal, which is just 25 wholes. So since I moved that twice, I need to move this one twice as well, and then I can put up the decimal. So 25 cannot go into 1, 25 cannot go into 12, 25 can fit into 125 5 times, and I know because 5 quarters. So 5 times 25 is 125, and my answer is just 5 decimal, which is just 5. So it's equivalent to just having 5. Okay, the problem that I want you to try is 72 hundredths divided by 1 and 2 tenths. Okay, so now that we've did our problem of the day, let's get started on our lesson for the day. Our objective or our goal today is, today I will subtract fractions with regrouping using an algorithm, period. Okay, so our last video we did something very similar. We subtracted fractions with regrouping, but we did it with an area model. Today we're going to use an algorithm for it. So we're going to get away from drawing our area models. Okay, so let's look at our vocabulary. The first thing I see is they're reminding us what a fraction looks like in the two parts of a fraction, a numerator and denominator. They're reminding us about common denominators because when we add and subtract fractions, we always need common denominators. They're reminding us just what vertical and horizontal looks like. Simplest form, we were using the GCF to get to simplest form, the greatest common factor, and then we're not going to worry about these. Okay, so let's look at our steps. Our first step says we're going to multiply the numerator and denominator of each fraction by the denominator of the opposite fraction. And we did this in a few lessons ago. Then we're going to rewrite the subtraction problem using a common denominator. Here's the new step. If regrouping is required, we need to decompose. This is where we're going to get into the borrowing. So when we did the area model, we had to take one of the holes and cut it up. We're going to do something similar, but we're not going to actually have the visual. Then we're going to subtract fractions. Remember, when we subtract fractions, it's numerator only. Then we're going to subtract the whole numbers and then simplify if needed using our GCF. Okay, so I'm going to get started on my problem. Here is my first problem, and it says 5 1/4 take away 2 2/3. Okay, so my first thing is I prefer to write these vertically. I think it works a little bit easier for me, so I'm going to say 5 1/4 take away 2 2/3. Okay, so I'm going to look at my first step. Multiply the numerator and denominator of each fraction by the denominator of the opposite fraction. Okay, so for this fraction, I'm going to look at this denominator, and I'm going to multiply it by 3/3. And remember that identity property, because this is equal to 1, I'm not really changing this at all. Okay, so what happens is I get 5, and 1 times 3 is 3. 4 times 3 is 12. And then for this one, I'm going to multiply it by the opposite denominator, which is a 4. So it's going to be by 4/4. So my whole number is going to stay. And the reason the whole number stays is because 2 times 1, this is equivalent to 1, is 2. So 2 times 4 is 8, and 3 times 4 is 12. Okay, so I did step 1. I multiplied the numerator and denominator of each fraction by the denominator of the opposite. I rewrote the problem with my common denominator of 12. Now it says step 3, if regrouping is required, decompose or unbundle the Minuend, which is the top one. Okay, is borrowing required? Well, let's see. 3 minus 8. If I have 3 parts, can I take away 8 parts? No. So I'm going to have to borrow. I'm going to have to take one of these holes away. Okay, when I take one hole away, I'm left with 4 holes. Now I want you to visualize what would happen with that hole. I'm going to take that hole and I'm going to cut it up. When I cut that hole up, I cut it up into 12 pieces. So when I cut the hole up, it's into 12 pieces, but I already had 3 pieces. So now I have 4 holes and 15 pieces because all I did was took one of these away and cut it up into pieces. So now I have enough parts to continue my problem. Okay, so now I'm going to subtract the fractions, numerator only. 15 take away 8 is 7/12. And then subtract the whole number. 4 take away 2 is 2. And then simplify if needed. This is where it's nice to know your prime numbers. I know 7 is prime, so the only factors of 7 are 1 and 7, and neither of 7 is not a factor of 12, which tells me that one is already in simplest form. Okay, let's try another one. A box of soccer game programs weighed 4 2/6 pounds. After distributing some of the programs, the box weighed 1 3/5 pounds. What was the total weight of the soccer game programs that were distributed? Okay, so again, I like to set it up vertically. So 4 2/6 take away 1 3/5. Okay. So step 1 is we are going to multiply by the opposite denominator. So I'm going to use the 5 for the top. So times 5/5. And I get 4. And 2 times 5 is 10. 6 times 5 is 30. Now for the bottom, I'm going to use the opposite denominator, which is 6. So 6/6. So 1. And 3 times 6 is 18. 5 times 6 is 30. Okay, so I've done steps 1 and 2 now. Step 3 says if regrouping is required, decompose. Well, if I have 10 parts, I can't take away 18 parts, so I have to decompose. So I'm going to take one of these holes away, which leaves me with only 3 holes. And what I do to that hole is I cut it up. I partition it into pieces. So I'm going to partition it into 30 30ths. But I already had 10 30ths. So I actually have 3 and 40 30ths now. And I'm going to take away 1 and 18 30ths. So 40 take away 18 is 22 30ths. 3 take away 1 is 2. Okay, so I obviously know 2 is a factor of both, but if I wanted to find the GCF, what I would do would be do my factor table for my smallest number. 1 times 22, 2 times 11, 3 doesn't work, 4 doesn't work, 5 doesn't work, 6 doesn't, 7 doesn't, 8 doesn't, 9, 10, 11 repeats. So 22 is not a factor of 30. 11 is not a factor of 30, because remember I go greatest to smallest. 2 is, which means the GCF is actually 2. So when I divide by 2 over 2, I get 2, and 22 divided by 2 is 11. 30 divided by 2 is 15. So my answer is 2 and 11/15. Okay, ladies and gentlemen, let's try one together. We're on page 118. Our first problem says 4 take away 1 and 2/5. Okay, so we're gonna set it up. Now this one's really different because I don't have the opposite denominators, so I can't really do that step at all. What I do realize though, when I go, I have nothing, so I can't do nothing take away 2/5. So I obviously am gonna have to borrow for this one. So when I borrow, I take 1 away and I cut that 1 up into 5/5. So notice this one I had less steps because it was a whole number. So 5/5 take away 2/5 is 3/5. 3 take away 1 is 2. And then my final step is to simplify. Well, 3 is a prime number, which means if I did the factor table, the only factors of 3 are 1 and 3 is not a factor of 5, so that means it's simplified. Okay, let's look at our next one. Nancy has a piece of fabric that is 2 1/2 yards long. She uses 1 5/8 yards to make a craft. How much fabric does she have left? Okay, so let's set up our problem. 2 1/2 take away 1 5/8. Okay, now because this one does have fractions, we're going to be multiplying by the opposite denominator. So for the top one, we're going to multiply by 8/8. And we get 2 8/16. And for the bottom, we're going to multiply by 2 over 2. So we get 1 10/16. Okay, now that we have common denominators, we're going to regroup if we need to. So 8 minus 10 is not possible. So let's take 1 away. And that 1 that we took away, we're just going to cut up into 16 out of 16 pieces. But we already had 8/16. So now on top, we have 16 plus 8 pieces is 24 pieces. And on the bottom, we have 10 out of 16. So we have 24 take away 10 is 14/16. 1 take away 1 is nothing. Okay, so now we want to divide by the GCF. Again, so we could make a table, a factor table for 14. I'm going to run out of room. 1 times 14, 2 times 7, 3 doesn't work, 4 doesn't work, 5 doesn't work, 6 doesn't work, and 7 repeats. Which means My factors are 1 and 14 and 2 and 7. So 14 is not a factor of 16, 7 is not a factor of 16, but 2 is. So 2 is my GCF. So let's divide by 2 over 2 and we get 7/8. Okay, ladies and gentlemen, you have the next couple pages. Oh, I'm sorry, you have this page, and then I believe your teacher will be assigning you some other pages. Have a great day.